you have a 45, 45, 90 triangle. And if I were you, I would put this, not that, I would put this on your cheat sheet. Just that generic 45, 45, 90 setup so that you make sure you have the right setup. Okay, so write that on your cheat sheet so you know what you're doing with it. What is X here on number 10? X is 20, right? These two, because they're the legs of an isosceles right triangle, are the same. So X is 20, making Y 20 rad 2. It's your X rad 2, okay? There's nothing to reduce. That's as reduced as you can go with that. Right? You can't, what do you mean by reduce it? Like plug it in?
The lower it gets, you cut it in half. I don't know, maybe.
Yeah, I don't know what you're thinking of there. Okay, number 11. Now they gave you this x rad 2 side. So what you do is you set that equal to x rad 2 and you solve. I don't know if Ornay gave you a shortcut. Do you know the shortcut to this?
Oh, yeah, the rad 2 or rad 2. Yeah. The rad 2 or rad 2.
That's not the shortcut. That's the long version. Cut the number in half, multiply by rad 2, okay? So if you see this side, you can just cut it in half and multiply by rad 2 to get your two legs, okay? But if you don't remember that shortcut, that's fine because you would just solve for x. So if you divide by rad 2, this is gone. Now you have 18 over rad 2. The issue is you cannot leave radicals in a denominator, ever. It is not the simplest answer ever. So what you need to do is multiply by 1, but we write that 1 as rad 2 over rad 2, okay? So it's 18 rad 2 on top. What's rad 2 times rad 2? Rad 4, which is 2. Okay, so 18 over 2 becomes 9, and then times rad 2. So either way, shortcut or no shortcut, you're getting the same thing, okay? All right, the other thing I would put on your cheat sheet is the 30, 60, 90. Here's the 30, here's the 60. In a 30, 60, 90, you have x for your shorter leg. What's your longer leg? What's this side? X rad 3, and 2x for the hypotenuse, okay? So in number 12, what side do you have? You have what? You have the hypotenuse. You have your 2x side. So if 20 is 2x, then when you divide by 2, x is going to be 10. Okay, that's this side. Your shorter leg is always across from the 30. Okay, so what is y? 10 rad 3. Okay. Okay. Then we move into trig. So SOHCAHTOA, something good to put on your cheat sheet.
That's what I thought. You had to cut it in half.
Oh, you were doing the 30, 60, 90. Yeah. Okay, so SOHCAHTOA, make sure you're spelling it right. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent, right? You three? You good? Okay, so on number 13, where do you always start the problem? From the angle, okay? So if our angle is here, which two sides are represented? This is your opposite, this is your hypotenuse, right? So that is what? Sine. So it's sine 33 equals x over 14. How do you solve for x? Multiply by 14. So you multiply by 14. This is what you're going to plug into your calculator, which came out to what? 7.6. Okay, so that would be your answer. X is 7.6. Questions on that? Okay, how about when you're solving for the angle? What's different? You use the inverse, right? So from the angle, which two sides do you have? The adjacent and the hypotenuse, so that's cosine. So you say cosine of the angle is 9/20, right? How do you solve for that angle right now? Plug it in as the inverse, right? So you're going to plug into your calculator. Actually, I'm just going to write it here. The inverse. Are you girls about done back there? You're going to plug this into your calculator, okay? Inverse cosine of 9/20. You get, where did I put it? 63.3 degrees, or to the nearest degree, 63 degrees, but this one was 63.3 because we said round to the nearest 10th. Typically, degree-wise, we just say round to the nearest degree, okay? 15, what are you using? Which trig function?
I don't know, man.
From the angle,
No.
you have opposite and adjacent, okay? So this is your opposite, this is your adjacent. So you're doing tangent. So it's tan 68 equals 6/x. And this is the one that often gets done wrong. You don't just multiply by 6 here, right? What do? Multiply by x. So that'll get the x out of the denominator. So you have x tan 68 equals 6 right now. You then divide by tan 68. Okay, so this is gone. You plug 6 divided by tan 68 into your calculator. No, this isn't inverse. Inverse is only if you're solving for the angle. Maybe write that on your cheat sheet. Only use the inverse when solving for an angle. Okay? And that one comes out to 2.4. Okay, that was 15. All right, 16, you're leaving your answer in simplest radical form, but how do you even get to an answer here? You what? Pythagorean Theorem? That's the one. So if we do Pythagorean Theorem here, Brett, turn around. Quit. What is our standalone? What's the number by itself? 4x or 18? The 18, right? So you're going to do 4 squared plus x squared equals 18 squared. So take away 4 squared. 18 squared minus 4 squared is 308. Okay, and then you take the square root of that. And when you square root 308, it is not a pretty number. So instead, you need to figure out what perfect square goes into 308. What'd you get? 4? 4 and 77. So the perfect square is 4. The one that you can't do anything with anymore is 77. So as simplest radical form, what is that answer? 2 rad 77, right? You take the one that's actually square rootable and you square root it. The one that isn't, you leave as 77. So 2 rad 77. Okay? Questions on that? You think you what? Oh, okay. Okay. Okay, 17, law of sines. This is the one that I wrote down for you on the sheet. Sine A over A is sine B over B, okay? What is a capital A versus a lowercase a? Capital A is the angle. What's the lowercase a? The side across from it, right? Okay, so if you label this, ladies, you with me? A capital A being my 112, what is my lowercase a then? The 15, okay? A capital B being my 22, then my lowercase b is the x. So if you label your parts like that, it makes it a lot easier to solve them. You didn't have to solve for y, it just asked for x, so forget that y. So you're doing sine 112 over 15 equals sine 22 over x, sorry. How do you solve that? Cross multiply it. So you're gonna do x sine 112, sorry, equals 15 sine 22. So then divide by sine 112. Be careful with this because your calculator starts a parenthesis here. So if you don't finish it off, it gets confused. Make sure you finish off your parenthesis or just hit enter. 15 times sine 22, enter, then divide by sine 112. That'll get you the same answer. And that comes out to what? 6.1. Okay, questions on that? Okay, then law of cosines is the one that says a squared equals b squared plus c squared minus 2bc cosine a. Okay, so you're going to plug that in. What is my lowercase a in this problem? What? 18. What's your lowercase a? The x. Here's your a. What's your lowercase b? 81 or 72, right? Those are interchangeable, doesn't really matter. So this would be b, this would be c. What is the 50? That's the capital A, okay? So if you're plugging that in, it's x squared equals 81 squared plus 72 squared minus 2 times 81 times 72 times the cosine of 50. Okay, the beauty of this problem is you can plug all that into your calculator and be done. We don't give you the ugly one that you had to rearrange. We give you this more simple version of it. So you should just be able to plug that in as you see it, and then you'll have your x squared, and then you need to square root it to get x. Okay, so let's plug it in real quick. 81 squared plus 72 squared minus 2 times 81 times 72 cosine 50. Take the square, so you should get 4,247.5. Take the square root of that, and you get 65.2. Oops, sorry. This was what number? 4,247.5. Keeps going. So take the square root, you get x equals 65.2. Okay. Questions on that one? Okay, last one, and then if you have any other questions, you can ask, or you can get going on tonight's. This says graph KLMN and the image. KLMN is already there for you. But the image under a translation of negative 5, 1. What is a translation? A slide, right? You're just sliding to a new place. So where are you sliding? How far? 5 to the left, 1 up, okay? So K is going 1, 2, 3, 4, 5 left, 1 up. So this is K prime. Same thing for L. 1, 2, 3, 4, 5, 1 is L prime. 1, 2, 3, 4, 5, 1 is n prime. And then m prime is 1, 2, 3, 4, 5, 1. So your figure, your image, would be that. Okay? And then 20 and 21 we did not on the recording.
Can you go